Hello my dear friends. So in last video we discussed that whenever a capacitor is applied with external voltage, the charge will be formed. The charge will be stored in the dielectric in this way. First of all, the polarization process, formation of the dipoles. Okay, after that the net positive charge is displaced from net negative charge. Okay, so that there is a charge formation is there. Okay, the net negative polarity is displaced from positive polarity, so that what we can consider, a particular amount of the voltage is existing, okay, from in this particular, for this particular dielectric, which is equal to the voltage which you are applying. Okay, so that's what the meaning. Okay, so we'll see further. Sorry. So whenever the capacitor is there, okay, so this particular capacitor, whenever it is applied with external voltage, okay, the external voltage is applied to the capacitor. Inside the capacitor, okay, the capacitor construction is, okay, how it is. There is a two charged plates. In between the two plates, a dielectric is there. The voltage which you are applying will store the charges in this particular dielectric. Okay. So what I am telling here, the charge which is storing in the capacitor, or the charge which is storing in the dielectric material, is proportional to the voltage which you are applying for that. So that taking the proportionality constant C, which is capacitor, okay, so C is equal to, okay, so the Q by V, charge per voltage will be called as the, okay, capacitor. Okay, charge per voltage will be called as the capacitor. Capacitor is having the property of the capacitance. Flux linkages per current will be called as the inductor. Flux linkage per current. Here charge per voltage, capacitor. Okay, charge means its electrostatic field. Flux means it magnetic field. It is storing energy in the form of electrostatic field. That is storing energy in the form of electromagnetic field. Okay, that's what the concept. So that the Q is equal to CV. Okay, if you differentiate on both sides, d by dt of Q is equal to d by dt of CV, which will be is equal to the current which is flowing through the capacitor is equal to C into dV by dt. Okay, UV form. If you take V into dC by dt, where C is, okay, constant which depends on the physical dimensions. I am writing here C is equal to epsilon A by D. Okay, epsilon is the permittivity. Okay, A is the area of cross section of the plates, and the D is the distance, okay, which the plates are okay, displaced, which is D here. The area of cross section of the plates A, okay, and epsilon is the permittivity of this particular okay, dielectric material which you are using here. So that current flowing through the capacitor C is equal to d in dV by dt, and V is equal to voltage applied to the, okay, so the voltage which is available across the capacitor is equal to 1 by C integral IC into dt. Okay, so this is the voltage available across the capacitor, a current which is flowing through the capacitor. Okay, so these two formulas will be called as the Ohm's law in capacitor. Ohm's law in capacitor. Ohm's law in the capacitor. Okay, so this is what the concept. Now, okay, so take the power equation. So the power is equal to what? V into I. The product of voltage and current gives the power quantity. Already I explained. So that V into, okay, take the I, which is equal to C into dV by dt. Okay, going to the next slide. So that P is equal to V into C dV by dt. dV by dt. This thing we can also write it as power is equal to, okay, d by dt of CV square. If you differentiate this, of C constant with 2V, which 2V into dV by dt. Why? Because the dependent variable here t, so that V is available, dV by dt we have to take. So that this is what. But actual, the power is equal to rate of work done. So that d by dt is equal to power. So that the quantity which is available here is indicating the energy which is accompanied with the capacitor. Okay, I mean the energy stored in the capacitor. So that energy which is stored in the capacitor, is what? Of CV square. That's what I am concluding. Of CV square. Okay, so here we can see what is, okay, on which quantity, on which electrical quantity energy stored in the capacitor will depends is the voltage. Why? Because the C is the capacitance which depends on the physical dimensions. C is equal to epsilon A by D. Okay, so that the energy stored in the capacitor will be changes whenever capacitor once designed, the physical dimensions will be constant. Okay, so that whenever the voltage is changing, then the energy stored in the capacitor will be changes. The responsible quantity in order to store the energy in the capacitor will be what? The voltage. This is the point. Okay, same concept I explained in inductor. If the voltage is changing suddenly, okay, if the sudden changes in the voltage, if it is possible, sudden changes in the voltage if it is happening there, okay, it creates the sudden changes in energy which is stored in the capacitor. Sudden changes in the energy. Okay, sudden changes in the voltages if it is there, sudden changes in the energy which is half CV square, in the half CV square also possible. But from the basic physics law, okay, sudden changes in the energy is not possible. Energy change within the zero time is not possible. Okay, within the zero time, okay, within zero time, energy cannot change, cannot vary. So within the zero time, the energy change is not possible. So that within the zero time, okay, the voltage change also not possible. So that sudden changes in the energy across the capacitor is not possible. Why? Because the energy which is available there is controlling it. So that what we can conclude, okay, in the capacitor, sudden changes in the voltages is not possible. Sudden changes in the voltage is not possible. Sudden changes in the voltage is not possible. Sudden changes in the voltage is not possible. So this particular property we are also calling as the capacitance property. Okay, so which we are calling as the capacitance. Capacitance is a property of the capacitor which will not allow sudden changes in the voltages. Okay, so which will not allow sudden changes in the voltages. And another way also we can define. Capacitance is the property of capacitor which will create the electrostatic field. Okay, so this way the electrostatic field is created. Okay, this is the electrostatic field. Okay, initially the dielectric is neutral. Okay, there are no charges. There are no static charges. There are no dynamic charges. But external voltage is connected. When external voltage is impressed on that, okay, because of the polarization process, dipoles are formed. Dipoles are, we can consider as static charges. The static charge are creating electrostatic field. So that inductance is a property which will create the electromagnetic field. Capacitance is a property which will creates the electrostatic field. This is the conclusion. Okay, capacitance here is creating the electrostatic field. Okay, so we can define the capacitance as, okay, as a two types. Capacitance is a property of the capacitor which does not allow sudden changes in the current. Okay, and which is also creating the electrostatic field, or which is also storing the energy which is in the form of the electrostatic field. Okay, here we can conclude. Okay, so the negative charge, positive charge are displaced with the distance L. In the sense what? In the battery, okay, so from positive charge we will indicate like this, positive and negative charge. Okay, from positive to the negative, particular amount of the voltage is existing. Here also from negative to the positive, okay, so particular amount of the voltage is storing here. Okay, so that whatever the voltage which you are giving as input, okay, that is storing in this particular dielectric, okay, in the form of electrostatic field. So that whatever the energy which you are applying to the capacitor, that will be stored in the form of electrostatic field. That is the conclusion point. Okay, so this is all about the capacitance. Energy stored in the capacitor will be half CV square. Okay, and Ohm's laws in capacitor. Okay, so these are the concepts. Okay, so this is all about the capacitor. Okay, another way we can see here. So current across the capacitor is equal to C into dV by dt. We define like this. Okay, we derived this. Okay, for example, if the capacitor is allowing sudden changes in, okay, if the capacitor is allowing sudden changes in voltages, okay, so that, I mean, sudden change in the voltage in the sense what? Voltage change within the zero time, and a voltage is changing, okay, within 0 time, suddenly in the sense 0 time. So that if it is possible, what we can write it here, IC is equal to C into dV by 0. I mean change in voltage in the change in time 0, sudden change. So which will be is equal to infinity. If the current flowing through the capacitance, is infinity, if the IC is equal to infinity, then voltage change suddenly is possible, then otherwise not possible. If you apply IC is equal to infinite amount of the current if you are supplying to the capacitor, then the sudden change in the voltage is possible for the capacitor, otherwise is not possible. This is an ideal. Infinite amount of the current you can't supply, so that here is not here voltage change within the 0 time also not possible. Okay, so this is all about the capacitor, and the capacitor units are farads. Okay, the ranges will be microfarads, okay, picofarads, like that will be there. Okay, inductor also we forget to mention. Okay, the henries are the units of the inductor. Okay, millifarads, millihenries, like that we will that is the range. Okay, coming to the resistor, ohms, kilo ohms, mega ohms, ohms, like that, these are the ranges. Okay, so this is all about. So with this we discussed about all basic parameters of electricity, which are RLC parameters. Okay, so that's it. So for more videos like this, okay, please subscribe to my channel. Okay, so thank you.